Okay, this is my lecture on global variables, local variables, scopes of variables, or sometimes called lifetimes of variables. I have my program loaded up here. This is available on D2L. And I have a little notepad here. I'm just going to create my own memory map, just like I do in class when I write it on the board. I'm going to run the debugger, which is not perfect in how it displays variables, but we'll work with it. And I've put, by left clicking, I put a stop sign up here so that when I go to debug, start continue, if the watch window doesn't show up, you have to go down to debugging windows and select watches. That'll bring up this window. Right now, it only knows, as it comes up, it only knows about this X and this Y. It hasn't assigned them yet. I also want to see these ones, so I'm going to do a watch, left click when the cursor's over it, right click to put the watch in. Oh, no, sorry, not a break, but just a watch. There we go. And it's a side effect of the debugger that B and C ended up and A all ended up nicely at those values. It doesn't quite know what to make of which X you're doing, but let me execute these first two lines, 16 and 17. All right, hold on. Now I'm going to update my memory map here. And this variable X, I have two variables now, an X declared here and a local X that's local to this main here, and that has the value 5, and Y has the value 20. The next time I look for the X, if I kind of think of the memory map as starting from the bottom, if I'm looking for a Y, I stop when I find it, it's 20. If I'm looking for an X, I stop when I find the first X. That happens to be 5. Now I've set up this do while loop just to give myself another level of scope. And so in between the brackets here, so from here down to here is one scope. Now I have another set of brackets between here and here. This kind of creates a new possible level of variable declaration. And inside this do while loop, and I'm only going to execute it, it's only going to go through once and then not do it again because I have this false here. But I went down here, declared a new X, and on line 20 that implies that I have yet another X here, which is empty right now. Here it shows up as one of those bogus really large numbers, which means it hasn't been initialized. Let me run the next two lines, 21 and 22, and you'll see the 50, 50 went into Y, so this got changed. And it went by kind of fast, but this X went to 50. And then we hit this for loop, and as soon as the debugger hit this for loop, it sees for, declare a new variable X of integer type. And it's not initialized yet, but if I do my memory map, kind of starts out at a -2, but as soon as we do a couple, the first line, you'll see that it went to 0, initialized X to 0, and now if we go next line through this a few times, you'll see it acting like a for loop. It's just counting up until it reaches 9. So let's see. I'll get up till I get to 9 and I'll stop. Alright, so now I'll update my memory map I'm keeping track of by hand. It has 9. We still have an X in there that has 50. We still have an X that has 5. And we have some X that's not ever set. As soon as I exit this for loop, now the 9 is going to go away. See, we failed the for incremented X. We didn't see it, but it failed the for loop, and now we exited the for loop, and you see how this 50 X went back to 50, so this variable actually disappeared. that memory that it took up is now available for something else. And let's look at our printout here. It's just printing out the values. We'll see what x is 50 and y is 50. When it hits this C out line, again, it kind of starts from the bottom and looks for the first x and looks for the first y, stops there, doesn't look further. Now let's run this for loop again, but here there's no integer declaration. That means we're not creating a new variable, a new memory location. So when it sets x to 0, it's actually setting this x to 0. And by consequence, this x to 0. So let's, next line, x went to 0. I'll update that here. And it's going to do the same counting routine until I'll stop it when it gets to 9. So that's at 9. I'll update my little hand manual memory map. Now increment x to 10. It's going to fail the condition check and go down here, but it still has the value 10. And again, we haven't got there yet, but we still have these other x's up here. Okay, we're going to print out that value 10 over there. And you'll notice as soon as I did that, it went to this line. While false means while, and this is a false. I don't need to have an equals, it's just false. False means that it doesn't keep looping. A do while loop only keeps looping as long as whatever is in here is a true. I had a false, so it exits just once. When I exited the do while loop, meaning I went past these brackets, outside of those brackets, it meant that that 10 and that x went away. And so that's why x now has the value 5, because I'm watching, okay, here's my y, and the first x I encounter has the value 5. That 5 stayed in there. It wasn't touched while I was doing all these for loops and stuff. Let's keep going through. We're just going to print out x and y. Now let's look at how global variables work, especially with respect to functions. And now I'm going to set those global variables, the ones that I had set or defined up here. Okay, let's go into that one. Next line. Next line. You can kind of see B and C being updated here. I'll do the same thing here so I can keep track of it. There's a 6. And then we'll just print those out. A, B, and C. 17. A still had that value 17, 4, and 6. Now here I want to be careful. I want to execute this function. If I hit next line, I'll skip over it. Actually, I want to do something called step into. All right, so as soon as I call the function, it takes my little yellow arrow, and now it says I'm down here. This changed a little bit as well. You notice I lost the B or I lost the X and the Y, and now I have a function argument C. So this is telling me that I have a function argument C. It has the value of 42.79982 or 992. A little rounding happened. This was 42.8. Internally, it represents itself as that. I'll go down here and I'll update. So I have a local variable only visible within the function. Oops, C. And that has, I'm just going to write 42.8. And I also have a local variable B, which bogus value because I haven't assigned it yet. As soon as I hit next line there, okay, it updated to 2.3. And if I print out, by the way, my A is still that. This is a little confused. The watch window is not perfect. I still have a B out there. I just can't see it. It still has the value 4. Again, kind of going from the top, I have a B and a C. I can't actually see X and Y, and I'll show you that in a minute, but that's the B I see. So if I print it out, on the screen, I'll see 17. Okay, that didn't change. That's good. I'm printing out this local value of b, not the 4 that it was before, because the computer can't see it. It only sees the first b. And we'll print out the c. And c does not have 6. It has, you know, the first one it sees is the 42.8. Now we'll assign a. And you see it changed up here, which means I'll change it here. Okay, now we're at the end of the function. I'll hit next line. And see, we're done with the function. There was nothing to return because it's a void. We come back up here. You'll see that my b and the c are now 4 and 6. I lost all those intermediate values. Exiting the function also means that these two local variables that were only defined within the scope of the function disappear. And if I print them out, of course I get to what they are, 5, 4, and 6. Now let me make a slight change to the program. Let me abort it. And I'm going to, you know, looking at my memory map, I have a x and a y here. I mean, I have there were a 5 and 50. Let me do cout. You know, they were kind of in my memory map. They're in the memory. Let's see if I can print them out. X equals. Okay, let's see if we can see what the value of, you know, this x that I had declared here. Let's see if we can display it in the function. I mean, it's there. I called the function. I'm within that scope. Let's see if we can see it. And I'm going to compile it. And that works. But let's try the other one. So you notice I had x. The question is, which x am I printing out? Am I printing out this x or this x? So let's try seeing if we can see y. Okay, now that x that I did in there, it was printing out, was accessing the global one. This y, I kind of want to say, well, I guess I'm going to think it's this one. I mean, that's declared there. It's before the function is called. Let's do a compile. And you see I got a not declared in the scope. The way the compiler works, when it compiles, it first sets up, and by the way, since I stopped the program, I guess these all disappeared, which is fine. You know, when the compiler parses the program, it sets up these global variables, and then moves down to the functions and does the main code. So here it moved down to the function. Had no problems kind of knowing that C and B were there, and that's fine. Those were local, not part of the memory map yet. Came down to X, it sees an X. Which X are you talking about? Okay, well, there's a global variable X. We know what that is. Comes down to this line, sees a Y. Does not see a Y in the variable list. Doesn't know anything about it. So can't do that. So just to kind of review, within the main here, so any code that I have kind of first looks, is it declared within a for loop? Use that one first, then go up and look at this one, then go up and look at this one, if it exists, and then at last count go up and look at this. But because I declared X as a variable here, within main, I'll never be able to access this. This is global. On the other hand, I can access B and C because those aren't declared anywhere else. And there's, in the function, I had variables B and C, and I could use them. And I could also use any variables that I had defined as global. So global variables I can use in the main part, and I can use in the function, as long as I don't redefine them or reinitialize them or redeclare them. Now before I finish, I think there's just a general practice. It is kind of confusing when you have variables all the same name. So bottom line is probably don't ever have any variables, no matter what scope they are, that have the same name. Sometimes you might say, if you have to have a global, you can say global A, then in your program, if you use them, you know that they're global, they're not local. But just try and not have the same variable names.